what is multi-user MIMO and massive MIMO? Sorry, multi-user MIMO and single-user MIMO, right? So as you see, single-user MIMO is like you'll be serving only one particular user, right? At a given point in time, you'll be serving beam or coverage only to particular UE, correct? Beam will be served to one particular UE. Whereas if you see in whereas if you see in multi-user MIMO case, which is a very latest technology compared to, so whatever the MIMO that you are having now is all a single user MIMO. Okay. So multi-user MIMO is being developed and it's very complex process. Okay. Because you need to allocate multiple beams to the multiple users, right? You have to, your G-node B should be capable of, should be intelligent enough to, direct beams towards individual UEs, right? Multiple UEs at the same time, same interval, right? So that is called multi-user MIMO. So, so that this multi-user MIMO is only possible with massive MIMO and beamforming. Without massive MIMO and beamforming, right, you cannot achieve multi-user MIMO. So why do we require multi-user MIMO? Why can't you? I mean, you can say that okay, single-user MIMO is good enough. Why do we need multi-user MIMO? First of all, do you think single-user MIMO is good enough? Is there any disadvantages with single-user MIMO? Anyone? I mean, so first of all, you understood what is single-user MIMO and multi-user MIMO, right? I mean, why do you think multi-user MIMO is beneficial compared to single-user MIMO? Or what is the drawbacks with single-user MIMO?
Numbers of users are used now if you are using multi-user MIMO. And if you are using single-user MIMO, there is a single user for that.
Yes. So whatever you are seeing, right? Whatever the throughputs that you are you are right. Whatever you said is correct. So whatever the single user MIMO can deliver, right? The throughputs is only per user basis, right? I mean, your overall system will be all be defined only on the single user perspective, right? Only particular user it can give more data or less data, right? But whereas in multi-user MIMO case, okay, so the transmitters, I mean, multiple antennas are used to serve only one single user, right? Here in G-node B side, even though you are using some 4 antennas, it will be delivering only to one user, right? But with multi-user MIMO, if you have especially more number of antenna elements, you can serve more number of users, right? So you can give 4 antenna elements here and 4 antenna elements here. Like this, you can have around 16 users with 64 by 64 TX, right? You can accommodate almost 16 users at a time. For a single TTI, you can accommodate almost 16 users, right? Whereas here you are accommodating only one user in single user MIMO case, right? So that is the benefit. So you can able to add up more number of users to, I mean, you can send data to multiple users in a single scheduling interval. Okay. So that is benefit of having multi-user MIMO. So how did this achieve? Okay. How is it achieved as part of your massive MIMO? How it is beneficial with the implementation of massive MIMO? So this multi-user MIMO cannot be done with the existing MIMO technology like 4x4 or 2x2. You cannot do that antenna element, this kind of antenna configuration, MIMO configuration. You cannot do multi-user MIMO. So that's where you need massive MIMO. Okay. How this is done is basically, for example, if you see, each UE will be capable of only 4 antenna elements, correct? 4 antennas is supported maximum as of now, correct? UE is supporting 4 antennas, but whereas base station has 64 by 64 massive MIMO configurations. Let's assume that. That means it can support, ideally, it can support 64 layers of streams that can be able to send to the UEs, correct? From the G node B, it can send 64, 0 to 63 layers of data it can send, ideally speaking, right? So, but UE side, you are supporting only 4 antenna elements. So what you have to do, this 64, if you 4 antenna elements, you can send it to one user, right? And 4 to another user, right? You can accommodate basically more number of, almost 16 users, right? You're getting? So 4 into 16, right? 4 antenna elements, you can accommodate to one user, so that you can accommodate up to 16 users. Is this clear? This is how multi-user MIMO will be done in the massive MIMO or massive MIMO cases. Okay? Did you guys get it, or you have any doubt? Hello? Hello? Can you guys hear me? Hello?
Yes.
Okay,
Yes, yes.
so is this concept clear? What is multi-user MIMO and how it is
Yes.
implemented, how it can accommodate multiple users, right? Okay. So how does implementation is done basically? So in massive MIMO array, for example, 64 antenna elements, but you need to have 8 to 16 RF chains, because you need to have it can accommodate up to 16 users, right? So you need to have separate RF chain for all these users, correct? So that is one implementation aspect. And then another one is you need to have beamforming techniques like digital beamforming, hybrid beamforming, right? Because you need to direct beams towards the multiple users, right? So currently, whatever you have is single user MIMO, where you can basically have one beam dedicatedly connect, one UE specific beam can be dedicatedly connect to the your UE, right? Single user UE. But whereas in multi-user MIMO, you should have multiple beams, right? So you need to have almost 16 beams in case of 64 TXRX configuration, right? So you need to have multiple beam forming, beam formed needs to be formed, and very in a short time interval, right? So that is one thing, implementation detail you need to look. And multi-user scheduling and spatial separation, right? So you need to also able to have dedicated beams for individual use, and the scheduling is also has to be done in multiple users, right? So that is also one of the implementation aspect when it comes to multi-user MIMO. So you should be able to schedule multiple beams for the multiple users, right? That is one thing. And CSI acquisition, right? So before even scheduling, right, you have to know what are the channel conditions of each of these users, right? For example, let's assume 2 users. So G node B has to listen to this particular CSI as well as this particular CSI, and accordingly direct the beams towards this, right? So that is another challenge, like our implementation details that G node B has to consider in order to support my multi-user MIMO, right? And so schedule and the G node B selects which use serve multi-user MIMO in each slot based on the spatial compatibility and channel quality and traffic demand. So it's not like always once G node B supports multi-user MIMO, it is not necessarily that Gnode B will be supporting multi-user MIMO always, right? It can switch to single user MIMO. So it will have a lot of conditions that have to be satisfied in order to support multiple users in each slot, right? So, for example, you have a slot like this. So it has to support UV1 here and UV2 here, UV3 here, like this. So it has to get the channel information of all this, and you have to make sure that, okay, in this particular slot, I can accommodate multiple users, right? So that scheduler role has become very important in order to, make an evaluation based on the UV's report. Okay, whether it can accommodate multi-user MIMO or single-user MIMO. Okay, so if it doesn't accommodate multi-users, it can switch to single-user MIMO, right? So that is one of the implementation aspect of multi-user MIMO. And what are the challenges? Okay, so challenges is too much for the multi-user MIMO, right? So RF calibration is required, like in order to process multiple arrays, right? Like we discussed over 64 antenna elements, 256 antenna elements, right? So you need to have RF calibration done for all these antenna elements in order to support this beamforming. I mean, this multi-user MIMO, and you need some technologies of recording algorithms like zero forcing minimum zero forcing receiver algorithms, and also minimum mean square error algorithm, or even AML based precoding has to be implemented in order to support um, this interference in order to reduce the interference because you'll be sending multiple beams across multiple users. There might be possibility that one UE might detect this beam instead of this, right, due to interference. So that is very critical. So you need some advanced technologies like so all this zero forcing and MMSE is already there, but you need some advanced enhancements to these existing algorithms. Also make use of AML based precodings, right? And another challenge is feedback and pilot overhead in case of high mobility, right? So this also have to be is a challenge, right? Because you have multiple users, all users will be moving in different directions, right? So you need to have solve this challenge as well. And hardware complexity, of course, and the overall system cost will be very high in case of development of